my name is Suborno Bari from Brooklyn College, and today we'll be doing a displacement lab. So let's head over and see what our equipment is. Now, the cool thing about this buggy is that it can flip when it's turned upside down. You want to see it? Yup, it can do that. So what we're going to be doing is we're going to have the buggy ride on over and over until its head reaches 100. Then it's going to do this. It's going to do the flipping motion, and now its tail is going to be at 100. So we have to be careful to stop measuring the head and start measuring the tail instead. And then we're going to wait for the tail to reach 0, and that's our second piece of data done. Our first piece of data there. Now we're going to do a second try. Start 2.83. 2.68 seconds. And T reverse average 2.39 seconds. Now you just common denominator these things. So here you have 40, here you have 60. So you have 3D over 120 plus 2D over 120 equals 5D over 120 equals D over 24. So that means that you get 2D over D over 24, which is 2 times 24, or 48 MPH.
That is correct. All right. Second, find the average velocity.
Well, you told me that just a second ago.
Okay, write the average velocity is 0. There is a notation for average velocity.
Yes, I know. Average speed is S with a hat, and average velocity is V with a hat.
All right, find the total. Okay, now I'm going to tell you the distance. Distance is actually 120. All right, so find the total distance and total displacement.
So the total distance is just going to be, well, 120 miles, 120 what? 120 bananas?
120 hot dogs. Actually 120 miles.
Okay, so the distance traveled then is 240 miles because you go to Cambridge
Sure.
and back.
Displacement.
And the displacement is 0 since you end up where you started. So
Show me the distance versus time gap.
So D, and what we're going to do is we start at 0, we go to 240, and it takes us 5 hours since we're traveling at, 240 over 48, yeah, that's 5 hours. So the graph is going to look something like that.
That's wrong.
What?
So 0 to 3 hour is diagonal but less steep, and 3 hour to 5 hour is more steep. 40 mile per hour is
correct. You're a very clever guy because it takes 3 hours to get to Cambridge, but you're going back faster, so it's a little steeper.
Don't make it look like a parabola, please don't.
Okay.
Exaggerate something. So diagonal line, diagonal line.
So,
one is less steep, one is more steep.
Yeah.
Okay, good. Displacement versus time gap, go ahead.
Okay.
Be careful.
Okay, this time I'll be careful, sir. 1, 2, 3, 4, 5. And this is T. And then we have 120, 240. So you go this way, and then
There is no leveling.
I'm so sorry. And you don't actually need
Displacement, I'm sorry. Okay.
and then you go back.
All right, excellent. Now, dt converted to st.
So you have ST at T equals 3, T equals 5. You just have 40, and then you have 60. So it looks like this.
No.
Oh, no, I'm so sorry. I'm dumb. I was thinking of the distance time graph. Yes, I know.
Okay, excellent, excellent. You can, yeah, there is nothing wrong to that. All right, VT graph.
Okay. 5 and 40, 60.
I'm sorry,
What?
40, 60. Okay. Find the area under ST graph, area under BT graph.
Okay, this is 120. This is also 120, so it's 240. And this is 120, and this is negative 120, so it adds up to 0.
What do you call the area under ST graph? Write it down.
Area under ST graph.
It's called distance. No, please don't. What are you doing?
What?
It's just called distance.
Yeah, I know. I'm just writing
Oh.
equals d of t.
Okay. So now write distance.
Yeah, I know. This is distance.
What do you call
and
area
this is
under?
displacement.
All right. Excellent. Excellent.